Got an important mail coming that you don't want to miss? Is just the beep of your phone not enough for you? Don't want to miss a notification when you're too engrossed into a game? Then this project is for you. So how this amazingly beautiful notification flag works is pretty simple. We'll be using a service called If This Then That, or IFTTT for short. It connects to almost all the popular websites and services on the internet and lets you take actions based on some context that you chose. This will call an API to Tweet.io, which is like Twitter but for IoT devices. A Wi-Fi enabled board will be looking for changes on a tweet address and it will turn a servo motor that raises the flag. So let's get building. The hardware side of the project is really simple. All you need is a ESP8266 based board. I won't recommend the ESP01 version, which I showcased in a previous video, since many people seem to have been having issues with it. My recommendation would be the Wemos D1 Mini, which is way simpler to use. Other than this board, the only other thing that you need is a servo motor, of which the red wire connects to the 5 volt, the brown wire connects to the ground, and the orange wire connects to the D4 pin. And that's the hardware done. The software side of this project has a few more steps than usual. It's not all that complex, but you do need to jump through a few hoops. The first thing that you need to set up is IFTTT. Go to ifttt.com and sign up for a new account. Now on the home page you will see a bunch of examples of what you can do, but we are going to create our own. Go to My Applets and select New Applet and click on this button. Here you need to decide what you want to happen to raise the flag. For example, you can choose Twitter, where the flag will be raised whenever you have a new follower, or whenever you are mentioned by someone else, or whenever a specific user tweets, or a bunch of other criteria. Or for Gmail, whenever you have a mail from a specific person, or if an email has an attachment, or some other thing like stock market, whenever a particular stock drops or increases, or there is a change by this percent. What I mean to say is that if it happens on the internet, it can be used. For this example, I'm gonna select Gmail, connect it to the Gmail account that I want to monitor, and then select any new email in inbox. Now for the that condition, search for webhooks and select Maker Webhooks. Click connect and then select make a web request. Now this is where we communicate with the Tweet.io service. How Tweet works is that you select a unique name for your device and then that device can have multiple keys. For example, I will choose the name Sparks ESP and then we have a key under it like Servo1. Now a good way to check if a name is taken is to go to tweet.io/get/latest/tweet/4/ your device name, in my case Sparks ESP. If the returning page says something like this, then the name is not yet taken. Now back to IFTTT. In the URL, type this but replace Sparks ESP with your own device name. Leave the method to get, change content type to text/plain and select create action. Click finish and you are done with IFTTT. PS, you can do all this from their Android app too. Now let's program the Wemos board. If you are using a ESP based board for the first time, download and install the Arduino IDE from the link in the description. In the IDE, go to File, Preferences and paste this URL in the Additional Boards Manager box and click OK. Now go to Tools, Boards, Boards Manager and scroll down to the bottom where you will find the ESP8266 listed. Select it and click Install and restart the IDE after the installation is complete. Now we need a library that is not included by default. Go to Sketch, Include Library, Manage Libraries and search and install the Arduino JSON library. That done, now download the code from the description and open it. Here you need to change a few things. Change Sparks ESP to your own device name and replace SSID and password with your own home Wi-Fi network name and password. Note that the servo pin in the code is 2 while we connected the signal pin of the servo to D4. This is because the GPIO naming scheme and the board naming schemes are different. Now you can connect the Wemos to your PC via USB cable. Select the correct board and the port from under Tools and click Upload. If you are using a bare ESP board that doesn't have a micro USB port, then watch this video to see how to program it. Now all you have to do is make an appropriate flag for the servo arm. Stick the board and the servo at an attention grabbing location, in my case the back of my monitor. Plug the Wemos board into a USB power adapter and you are good to go. An important thing to note here is that the flag once raised wouldn't go down on its own. You have to reset the board to show that you have noticed the thing. That's why it's a good idea to keep the reset button close to the edge where you can easily reach it. This is the project essentially done. Though I should mention some concerns that people might have. Number 1. The servos. It's not ideal to drive a servo directly off the Wemos board, but it's okay in short bursts like we are doing here. Number 2. Multiple flags. It is possible to set up multiple servos for different things, but the code at the moment is not set up for that. An alternate is that you can make multiple applets in IFTTT to raise the same flag. Number 3. The code. Yes, I know my code is horribly inefficient. Again, you are free to modify it and make it better. And that's it for this project. Drop a like if this video was helpful. Let me know in the comments how you like this project and if you are having any issues with it. Subscribe for more projects coming soon, and I'll see you guys in the next one.